Hey guys, this is packet 6. So we worked through these questions and we skipped this one. So if we have time, we'll come back. But so far we skipped this page and it looks like we only had a couple questions on here. So let's definitely get a few done on here. If we have some time, we'll jump to the other page. This says, what are equivalent forms of an expression? Okay, so let's see. It says, what is, I'm just going to jump to one question that looks pretty easy. What is the value of c that would explain the square? Okay, so if this was completing a square, that means this would be x by x. That would make a square. 14, that would have to be 7x and 7x. Does that make sense? Right, 7x. And so this would have to be 7 times 7 or 49. So the answer they want is 49. Cool? So what does this look like? Well, if you took 7 plus x times 7 plus x, when we FOIL, the first terms would be this. The last terms would be this. The inside terms here, the last two terms, 49. I get 4 terms, x squared plus 7x plus 7x plus 49. Notice these terms combine to get me the 14. Okay, next. I liked that, okay. What is the vertex form of this? All right, we've done this in sticker 4. So x is equal to negative b over 2a. So a is 3, b is negative 30, and c is 71. So we have negative 30 divided by 2 times 3. So 30 divided by 6 is 5. Now we're going to plug in x to find y. So f of x is y. We'll say 3 times 5 squared minus 30 times 5 plus 71. So this is 3 times 25 minus 150 plus 71. So we get negative 75 plus 71, or negative 4. All right, so we have our coordinate of our vertex. X is 5. Right? And y is negative 4. So we can put this in vertex function. So we are given f of x is x minus 5, because that's lying, squared, minus 4. Outside is not lying. Okay? That's in vertex form. I could have done completing the square, but I didn't. Okay? That would have been another way. What else could we do here? I think number 3 looks kind of like what we did. So it says, if the model is thrown in the air, and this is a frown, so it means I threw something in the air, it's a frown. So this would be my max, right? What is the altitude if it's thrown in the air? What are you going to be looking for if you're asked to find the maximum? I'm looking for the vertex, right? What are you going to be looking for if you're asked to find where the ball lands? All right, where the ball lands. So I guess this would be x, when the x lands. Right? So we want to know what x is at altitude, or y0. So this is also known as our x-intercept. Now it doesn't say to actually solve the question, it just asks us if we know what we're looking for. But let's go ahead and solve it. So let's find our vertex, that's a, b, c. X is equal to negative b over 2a, so negative 8 over 2 times negative 2. So we get 2. All right, now we know we can plug in x to find y. So y would be negative 2 times 2 squared plus 8 times 2 plus 5. So that'd be -8 plus 16 plus 5, or 8 plus 5 makes 13. All right, so our vertex, what are you going to look for at the max? That's the y value of the vertex. So if the vertex is at q time of 13, then this is my max, 13. Where are you going to be looking for when when y is 0? Okay, so we can set this function to 0, right? So this is, when is -2x squared plus 8x plus 5 going to equal 0? We'd need to factor. Okay, so I'm not sure if I'm up for this or not. 5, 1. No, I don't like that. So let me switch 5 and 1. I'm not getting 3. Yeah, so I'm not sure here. I can't factor this by hand, so I'm going to just leave that one as is. Okay, let's look at question number 1. Sue removed the plug from the trial of the drain. The volume is in gallons. Here's the model. Okay, so the model is a smile, right? Because A is positive, A is 4, B is -32, and C is 63. Which of the following would demonstrate to Sue the amount of time it takes to the drain to T? So T is X. So here it would go down, right? So that's going to be the amount of time it would take to drain. Look like it's going to be my 0, right? It doesn't look like it's my intercept. Here it looks like, when is the drain at the minimum amount? Okay. Right? Write the expression that will help Sue determine if the amount of time it takes to drain. So what would give me my minimum amount? It looks like my minimum would be my vertex, right? And these two are in my vertex form. So I have to figure out which one of these is appropriately in my vertex form. Okay, let's figure this out. First, we're going to factor out a 4, right? So subtract, let's get the 63 over there. So we get 4t squared minus 32. T equals -63, right? And then we can factor out this 4. Right? And then we could say, well, hold on a minute. What would I have to add to get it in vertex form? I can't take it. I forgot a t here, right? I still got this t here, right? And normally I would write x minus 2, or cut that in half, so 4 squared, right? So I'm lending toward this here. So, but how do I get that? So I noticed that -4 times -4 is 16, but then I have to multiply this by 4. So 16 times 4 is 24. 4, 5, 6, and that's 64. So technically I've added 64 to the left, so I still have to add 64 to the right. That's how I got 1 on that side, and when I scoot it back over, I get -1. Voila, I'm done. Nice work, guys.